Hi, welcome to our lecture on pre-calculus. Today's topic is sketching the graph of y is equal to a sine of bx plus c, or y is equal to a cosine of bx plus c. The lecture today is rather substantial, so it's not a mini lecture. Let's see how far we can go. Uh, if you want to solve this problem by uh, point plotting, as in the previous examples, it's not terribly hard or anything, but understanding exactly how does uh, having an input argument in the form of bx plus c is going to affect the shape. What are the transformations that are involved? That is going to require a little bit of work. So let me first go ahead and explain this uh, in the same style as in your textbook or software, and then come back and give a secondary explanation as to another way of looking at this so that we see the movements. So the issue is the following. So you remember that all of these problems we start with, say, sine of x, and then after that perhaps we talk about, well, what would the graph of x plus some number going to look like? Just for the sake of simplicity, let me just put, say 6. What does this imply? Well, we said it means you're going to shift left by 6. And then we said if you have a function, say sine of 2x, what would the number 2 going to do? This is going to compress the graph by a factor of 2. So this is compress by a factor of 2. We did both of these problems by point plotting, and also explain what kind of transformation, what kind of movement they imply. The issue is the following. If I have both of these, if I have 2x plus 6, what kind of transformation, what kind of a shift or compression is going to happen, by what amount, in which direction, and so on. I would very much like that you, at the end, you stop this video and then go ahead and try to discover by yourself, and come back and listen to the rest of the lecture to see if it matches what you thought. And if so, you are a very good candidate for studying mathematics. Now let's go ahead and take a look at the problems that we have here. So here's the first example. We want to graph 2 cosine of 3x minus pi. As usual, we are want to make sure that we get the x-intercepts, minima, maxima during one cycle of the picture. So what do we do? Well, start with the graph of cosine as usual. Cosine has these 5 points. So these are the main points of the first cycle. So we start from this maximum point, come to this x-intercept, go to this minimum point, go to the next intercept, go to the maximum again, and this is a graph of one cycle of cosine of x. Now several things to worry about. One is, what would this 2 going to do? What about the role of 3, and what's about the role of this minus pi? The role that 2 plays is rather trivial and is not going to be a challenge for us at all. We said it's a vertical stretch by a factor of 2. So if you want to do it at the beginning or at the end, it's all the same. The majority of the work or difficulty is what happens here, 3x minus pi. So let's go ahead and do this problem by a standard style of, so we have, we said we have, we can follow the problem by point tracking. So point tracking means you have this graph, It has 5 critical points. Identify them and see where do each of them going to go. So track each of the points and see what you get. Type 2 is by studying transformations. Transformation, just as I said before, we had said adding means to the left, subtracting means to the right, multiplying means kind of compression, and the issue is that these two interfere with each other. All the examples that we had before, whatever you were doing, one activity was not interfering with the other activity, and this is where well, the interference happens, and that's what makes the problem interesting. So if we want to do this thing by point tracking, we kind of go through steps just like as before. So we make a table. I have this what is that? We have 3x minus pi. 3x minus pi is the input. Later on we are going to come back, call it maybe x prime or something, and then cosine of this is the first step, and then our final step is to double this. That's not going to be a challenge at all. 3x minus pi, so we're just going to double that, and then we want to work our way back to x, get our x's, get our final values, and plot that. So that's rather straightforward. So we are going to say, as usual, if this is 0 or pi over 2 or pi or 3 pi over 2 or 2 pi, in each of these cases we are going to fill up the rest of the table. Well, how about here, cosine of these angles? We have done it plenty of time, and that's what makes it fast, that we have gone through this exercise before. So 1 0 minus 1 0 minus 1 is the cosine of these particular angles. Doubling them is trivial. 2 0 minus 2 0 2. So that was easy, except that I forgot to color it so that we keep our focus on the final two red colors. How about this x's? X's, we set the 3x minus pi equal to these angles. Figure out what the x is going to be, and that's going to be the numbers that we are going to have here. So I take 3x minus pi, set it equal to 0. So we are asking myself, when is it that this actually becomes 0? So I set it equal to 0, see what happens. So of course 3x is going to be equal to pi, so x is equal to pi third. So the x value at which this happens is when this is pi third. Then we are going to repeat this game with respect to each of these other critical angles. So I will have, so this was the first one, and then I go 3x minus pi equal to pi over 2. So 3x is equal to pi plus pi over 2. Take common denominator. We have done this several times. Divide by 3. So x becomes pi over 2. So now I have x equal to pi over 2. And then again, 3x minus pi is equal to pi, and so 3x is equal to 2 pi, and x is equal to 2 pi third. So this angle is 2 pi third. And repeat, 3x minus pi is, and now we are going after this angle, 3 pi over 2. So 3x is equal to pi plus 3 pi over 2. Take the common denominator. This becomes 5 pi over 2. Okay, 2 plus 3 is 5. So x is 5 pi over 6. I noticed I made a mistake here that, well, no, oh, that's fine. 5 pi over 6, and next, so let me write that here, 5 pi over 6. One more round. 3x minus pi is now final angle, 2 pi, and then this means 3x is equal to 2 pi plus pi, so that is 3 pi, so x is just equal to pi. So final angle, this was pi. Now these are fine as they are. To avoid the confusion with respect to the denominators and such, it would be better if everything has the same denominator. So I look at these things and say, what is the common denominator of all of these things? It's pi 6 is 6. It's better for graphing, I believe, that we write this as 2 pi 6. This is just x again, but I write it as 2 pi 6. I multiply this thing by 3, so it becomes 3 pi over 6. And then multiply this thing by 2, so it's 4 pi over 6. Multiply this thing by just 1, and that is 5 pi 6. Make everything have the same denominator, 6 pi over 6. Well, what is so great about this? The great thing about this is that while you already see is 2, 3, 4, 5, 6. You always get a progression of numbers. And that helps you to kind of position yourself easily in the picture. And as you see in the picture, in the graph, each block is also pi over 6. So this is giving you a little bit of help as to where to position your pen. So you're going to position your pen. First x location is 2 pi 6, means two of these blocks. So I'm going to be, this is my x. This is x, this is my y. So x is 2 pi 6, and I have to be at 2. So what has happened is that this point has moved over to there. Next question is, how about this intercept? Interestingly enough, that intercept is where it is right now, 3 pi 6, same as 3 blocks, same as pi over 2. That point stays where it is. Some interesting coincidence, but it's just that, a coincidence. Next, I have a hard time fitting both of these things here. So next is 4 pi 6, same as 2 pi third. 4 pi 6 means 4 block, and that means at 4 pi 6, where am I? At 4 pi 6, I'm minus 2. So this is 4 pi 6, and minus 2, I'm going to be down here. Then I'm at 5 pi 6, I'm back to 0. 5 pi 6 is here, I'm 0 here. And then 6 pi 6 is just, of course, pi back to pi, and I'm here. So the picture is squeezed and moved over. Now what is if you wanted to describe it, what is the compression, what is the movement? That is what I'm hoping some of you will take over this challenge of trying to describe what happened here by concept of transformation. What compression and what shift will do this? Okay, but let's go ahead and first get everything done by point plotting. So that's what we means by point plotting. We take the input, this is the input of your function, whatever is inside the parentheses. We set it equal to these famous angles. Well, why? Because it's so easy to figure out the cosine of these things. We can just quickly rattle off these things. And then whatever you do with that is also trivial. You just double, triple, whatever it is. So we are doubling here, so these numbers double. Slight work has to be done to figure out if this is the input or what is the x that causes that input. So I take that input, set it equal to each of these angles, and figure out the corresponding x. So that's why we did this 5 problems here. Then I said, for the sake of graphing, it's best to have a common denominator. Common denominator, this one I have to multiply by 2, this one by 3, this one by 2, this one just by 1, this one by 6, so that I easily see, look, it's 2, 3, 4, 5, 6 of pi 6. And who is pi 6? Well, pi 6, of course, is 6 of pi. So each of these blocks of the picture is exactly what I need to worry about and to consider in my graphing. So we started at 2 pi 6 is 2 pi 6, and the height that goes with it is 2. Next one is 3 pi 6 and it's 0. Next one 4 pi 6 and minus 2, 5 pi 6 and 0, 6 pi 6 and 2 again. Of course 6 pi 6 is just your pi. So what we have now is twice cosine of 3x minus pi. This is the graph of that one. The amplitude is doubled, but more importantly, we have some sort of a compression and we have some sort of a shift. And I hope you figure that out by the second half of this lecture. Okay, let's go to the next problem. Similar to this, same kind of a setup. It's a sine function. Sine function, the 5 important points of it are these. So I go from 0 to 1, back to 0, to minus 1, back to 0. So this is the grandfather function, sine of x, or grandmother function, sine of x. That's all. As usual, doubling is not a major challenge. Question is what is happening here, and that is where the crux of the argument is, what's going on there. So let's go ahead and make a table. So we said we are doing this by table method. So I make my table. So 3x minus pi over 2, is that right? That's what we had, 3x minus pi over 2. And then cosine of this 3x minus pi over 2. Finally, we double this thing, so twice cosine of 3x minus pi over 2. And then we want x, and sometimes we want to clean up x, so that's easy to track them by taking common denominators and such. So we write the x all over again. Now, angles again, 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Oh, I made a mistake here. It's not cosine, it's the sine, huh? So sorry for that. So this is sine, and this is sine. Okay, so back, sine of these angles, 0, 1, 0, minus 1, 0. Double, well, that's the easiest part, 2, 0, minus 2, and 0. What x is it that makes your angle to be 0? So I take this is the input to my function. I set it equal to 0 to see which x is responsible for this. So I say, let's start here, 3x minus pi over 2. I set it equal to 0, so 3x is pi over 2. So x is pi over 6. So x is pi over 6. Repeat. So 3x minus pi over 2 is equal to pi over 2. So 3x is equal to pi over 2 plus pi over 2, and that is just pi. So x is pi third. So pi third. And again, I made a mistake of, let me color them. 0, 2, 0, minus 2, 0. Those are our final numbers. Write it in red to subtract them. So pi third. Next, input being pi. So 3x minus pi over 2 being pi means 3x is equal to pi over 2 plus pi, which is 3 pi over 2, which means x is just pi over 2 divided by 3, so I get pi over 2. Now let's not go down too much, so I come back up here, and now I say input is 3 pi over 2, so 3x minus pi over 2 is 3 pi over 2, so 3x is pi over 2 plus 3 pi over 2. So you add them, common denominator 2, 1 pi, and 3 pi is 4 pi. So of course this is just 2 pi. X becomes 2 pi third. So now let's write 2 pi third, 2 pi third. One more round. 3x minus pi over 2 is equal to 2 pi. Can I summarize this thing? Yes, you can write the right hand side as x as x prime, and then solve it in terms of that, and use the same formula 5 times instead of reinventing the wheel 5 times. So it's called parametric style. Let me write it like this so that everybody comfortable with it. Pi half plus 2 pi. Take common denominator 2 pi plus 4 pi. So this is 5 pi half. So x becomes 5 pi 6. So that is our last number, 5 pi 6. Just as before, let's deliver everything to the same denominator. So this is 5 pi 6. Double this, so 2 pi 6. Triple this, so 3 pi 6. Double this, 4 pi 6. Meaning double numerator and denominator. Of course, we are not changing the x, we're just rewriting it some other side. This one, just as it is, 5 pi 6. What's the convenience? Convenience is just what you see, that you have 1, 2, 3, 4, 5, and that makes it easy for us to tick the points. So I have 1 pi 6 versus 0, so that simply means, let's indicate again, each of these blocks is pi 6. That is conveniently labeled for you. So you see it 1 pi 6, and we want to be 0, so that simply means our x-intercept is there. And 2 pi 6 we have ascended to 2, and then 3 pi 6 I'm coming back down here. 4 pi 6 I'm at minus 2. 5 pi 6 I am at back here. So yeah, this is squished into a smaller area. What is causing it? That factor of 3 is causing this. So that's the maximum. This is the next intercept. This is the minimum. This is the next intercept. So the name for this thing is a maximum point. The name for this point is minimum point. When you go to calculus, finding these things becomes a regular question. These are your x-intercept. These are your x-intercepts. What we got is the graph of 2 sine of 3x minus pi over 2. So 3 causes this thing to be squished by a factor of 3. Our shift is not pi over 2, if you notice. So I will be asking you that question at the end. How would you describe this? Let's go practice one more time. Let's be fast now. This is cosine So here's our cosine. Cosine, we go here, 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 and here. So this is the graph of our y is equal to cosine of x. Now what? We have, again, this is trivial, triple the height. 3/2 x plus pi over 4. So this is a little bit more crowded than the previous one. There's lots of fraction here, it's not a whole number, and there is some shift here, pi over 4. What does that do for us? So let's go make that a table. So we are going to have a table. So we have 3/2 x plus pi over 4, and we are taking the cosine of this, cosine of 3/2 x plus pi over 4. Then we are tripling this thing, so triple cosine of 3/2 x plus pi over 4. We are going to need our x, and if all x's don't have the same denominator, we need to put them in the same denominator just so that our life will be easier and we wouldn't be battling fractions in the middle of graphing and everything. So now what? So as usual, so we go through 0, pi over 2, pi, 3 pi over 2, 2 pi. Take the cosine, 1, 0, minus 1, 0, 1. Triple that. No problem. 3, 0, minus 3, 0, 3 again. And then here, a little bit of work is needed. So let's start. We have 3/2 of x plus pi over 4 is equal to 0. So this is our input. Which we are using there, that whole thing. It's going to take turn becoming any of these angles, and then so once we have these angles, we go ahead and figure out the x, clean up the x, and then go after graphing. So the step 1, 3/2 x is equal to minus pi over 4. So I multiply by 2, divide by 3. So x becomes minus 2/3 of pi over 4. If you want to simplify it or you don't want to simplify it, that's your choice. So this is minus 2 pi over 12, which you recognize as minus pi 6. So which one you want to write is your choice, minus pi 6. And then we repeat the game. So next time around, what if I have 3/2, so let's draw a line here. 3/2 x plus pi over 4 is equal to pi over 2. So 3/2 x is equal to pi over 2 minus pi over 4. Take the common denominator. 2 pi minus pi is pi over 4. So x multiplied by 2/3, it becomes pi 6. Okay, I multiplied by 2, divided by 3. So I took this, what happened here? So we took pi 4, multiplied by 2, divide by 3, just like what we did here. And then you can simplify this thing by 2. And then 2 times 3 is 6. That's how we got that. Okay, so you repeat each of these things for yourself. Next round, 3/2 x plus pi over 4 is equal to pi. So obviously I needed more space here. So 3/2 x is equal to pi minus pi over 4. And you take a common denominator because 4 pi minus pi, 3 pi over 4. So 3 half x, I can figure out x, 2/3 of 3 pi over 4. When you simplify that, 3's cancels, 2 and 4 gives you 2, or leave it as the way you want it. So this is pi over 2. Then what? And then perhaps I come here, and then 3 half of x. See, is it readable? 3 half x plus pi over 4. That is now, well, I did pi, now I do 3 pi over 2. So 3 halves x is 3 pi over 2 minus pi over 4. Take a common denominator. This becomes 6 pi minus pi, and that becomes 5 pi over 4. So x becomes 2/3 of 5 pi over 4, and this becomes 5 pi 6. Is that right? So this becomes 5 pi 6. So I write here, this is 5 pi 6. Thankfully, we are getting to the bottom of this. 3 half x plus pi over 4. Now I do the very last of these things. When does it become 2 pi? Well, figure it out. 3 half x is 2 pi minus pi over 4. Take a common denominator, 8 pi minus pi, 7 pi over 4. X is 2/3 of 7 pi over 4. So what is that? 7 pi becomes 6. So I get 7 pi 6. Now you look at these numbers. Maybe it's not all clear. Let's make them all same denominators. Minus 1 pi 6. This is 1 pi 6. This multiplied by 3 becomes 3 pi 6. Multiply by what? By 1. I don't need to multiply by anything. 5 pi 6. This is 7 pi 6. So essentially just one of them needed to be cleaned up here. So what does that tell me? Minus 1, 1, 3, 5, 7. How do they step up? How do you step up? Obviously you step up by 2 every time. Every time you go up by 2. What does that mean in picture? It means you are moving 2 blocks in the picture. 2 blocks. So first of all, we make sure we know what's a block here. Here's our block. This is pi 6. I start on the negative territory, minus pi 6, minus a block. So that means I am to the negative territory, and then versus 3. So I go minus 1 block and 3, so I'm all the way up here. Then pi 6 and 0. So pi 6 is 1 block. Let me erase this thing so it doesn't bother us. So 1 block was, of course, this is just 1 block, of course. So next I have pi 6 and 0. So at pi 6, I'm here. At so 2 blocks over. Now 3 pi 6. 3 pi 6, of course, we recognize that's pi over 2. That is where the negative 1 is going to happen. Negative 1 is here. 2 more is 3 blocks. 2 more, I'm at block number 5. That's my next crossover point, next intersect. And then I get to 7 pi. So 2 more blocks after that, 7. I go all the way to 7 here. So I'm so I start from here, come down, go to 0, go up here. So I'll have y is equal to 3 cosine of 3 half x plus pi over 4. So some squishing happens because 3/2 is larger than 1. That's going to squish the graph by factor of 3/2, like 1.5 times. This graph, this black one, got squeezed, got narrower by factor of 1.5. It's 3/2. Some shifting is happening. What the shifting is not pi over 4, is not this number. So that is what I'm asking you to think about. Well, what's going on here? The compression is always clear what the compression is. The shifting is a bit harder to figure it out. So you think for yourself, and let's see. Okay, this is I didn't put any space here, so let's make space. And no, wait. So let's write this thing. My input is 2/3 of x minus pi third. So that's my input. And then I am taking the sign of this input, sine of 2/3 x minus pi third. By the time you come to this much repetition, you might compress some of your table entries and then perhaps write twice that anyway instead of repeating this so many times. So once you get the hang of it, you probably make this thing a lot shorter than what I'm making it here. So of course we have our x. Every now and then we need to clean the x. So we have 2 columns for x. And then let me go ahead and make our columns substantial. And so 0, pi over 2, pi, 3 pi over 2, 2 pi, and sine 0, 1, 0, minus 1, 0, double 0, 2, 0, 2, 0, minus 2, 0. Okay, so once again we are going to take that input, set it equal to each of these 5 numbers, figure out what x has to be. So you can take these angles, call them, for example, angle A, famous angle or something, and figure out the x in general and find the x quickly by putting into a formula, or just go ahead and calculate like we have been always doing. So let's go through this thing, same style as before. So 2/3 x minus pi third is equal to 0. So 2/3 x is pi third, or multiply by 3 if you wish. Multiply by 3 now, so you get 2x is 3/2 of pi third. That's just pi over 2. However you do that, it's fine. And then keep repeating this. So now we have 2/3 x minus pi third is equal to pi over 2. Let's just go ahead and multiply by 3, just a slightly different flavor if you wish. Multiply by 3, what do you get? 2x minus pi is equal to 3 pi over 2. Just a slightly different flavor. 2x is equal to pi plus 3 pi over 2. Take the common denominator, it's 5 pi over 2. X becomes 5 pi over 4. Or if you didn't want to do it differently, it's just 2/3 x is pi third plus pi over 2. Take the common denominator, makes it 5 pi 6. Multiply by 3, divide by 2. 3/2 of 5 pi 6. So you simplify and you get 5 pi over 4. So plenty of styles of doing this thing. That's fine however you do it. that's one angle. That's another one. Let's go ahead and squeeze another one here, maybe 2/3 of x minus pi third. Now I'm going to set it equal to pi. So 2/3 x is equal to pi third plus pi. Take common denominator 4 pi third, multiply by 3, divide by 2. So 3/2 of 4 pi third, and that's of course just 2 pi. So we came to this angle of 2 pi. Notice that the points are spreading out. What is causing it? Do you see what's causing it? If you multiply x by a number less than 1, your 5 points spread out. If you multiply by a number larger than 1, they get compressed. So since you have a 2/3 here, it means the graph is going to be stretched out by a factor of reverse of this, 3/2. Yeah, follow that? So let's do one more. We have to do 3 pi half. So let me put it here. 2/3 of x minus pi third is 3 pi half. So that means 2 x third is pi third plus 3 pi over 2. Take my common denominator 6, 2 pi, and 9 pi. Is that right? 2 multiply 9. 2 and 9 is 11 pi 6. Now x, I multiply by 3/2. 3/2 of 11 pi 6. Simplify. This becomes 2, and that becomes 4. 11 pi fourth. So I got this number 11 pi fourth. Notice, much larger than what we are used to. One more, and let me do it here. So I'll have 2x minus pi third at the final straw. This is 2 pi. So 2x is equal to pi third plus 2 pi. Excuse me, 2 third x. Did I make that mistake somewhere? Okay, 2/3 x. So I take a common denominator here. So this is 3 pi and 6 pi is 7 pi. So x is going to be 3/2 of 7 pi third, which is obviously just 7 pi halves. 7 pi halves. So again, we look at these things, you see denominators all over the place. There's a 2, there's a 4, there's no denominator here. You can think there's a denominator 1, I have 1, 2, 4. So let's go ahead and multiply so that our x's have the same denominator. What do I need to multiply this thing by? I need to multiply this thing by 2. Common denominator is of 4, of course. So I need this to be 2 pi 4. And this is good as it is, 5 pi 4. I multiply this thing by what? What do I need to multiply this thing by? I want the denominator to be the same. I want 4. I want to see a 4 down here. So I have to multiply by 4. So that becomes 8 pi 4. How about here? Well, that's good as it is, 11 pi 4. How about here? Multiply by what? Multiply by 2. So it becomes 14 pi 4. Now, how are my numbers? Do they make sense? 2, 5, 8, 11, 14. Do you see the pattern? You see how much do they move by? How many blocks? So our thing is going to be pi fourth is going to be our basis block, and then we are going to move by 3 blocks every time we move over. 3 blocks to move over. Okay, once we get the hang of how many blocks we are going to move over, the problem becomes actually trivial. All I have to do is start at 2 pi over 4. So first of all, let's get the hang of our block. This is pi, and of course then our block is conveniently just what you see. So this is our pi over 4. This is from here to here is a pi over 4. I need to move two of these things. Well, I forgot to even to start with my sine. So here's my sine. So I go up, I come down, yeah, and I get my sine curve. So this is sine of x. Where do things go? 2 pi fourth is my start. At 2 pi fourth, I'm 0. So here's my starting point. Next one is at 5 pi. We said every time we are moving by 3 blocks, 1, 2, 3. So we make sure we don't mark the wrong points. That's my maximum. Okay, this is maximum. 3 more blocks to get the next intersection. 3 more blocks. That's going to be where? That's going to be here accidentally. Is that right? Well, yes. We said at 2 pi, which is same as 8 pi over 4, I moved 3 blocks. I came to the 2 pi. And then I move 3 more blocks to come to the I was supposed to be height of 2. Another mistake here. I was supposed to be 3 blocks, and I need to go to 2. Okay, sorry for that. So, and I need to come to minus 2. Okay, so our maximum is up here, our minimum is down here. 3 more blocks. 3 more blocks of 1, 2, 3. 3 more blocks, I'm here. And our last point is 14. So 4 and 4 and 4, 12, and 2 more is 14 blocks. Is that right? So now I draw my sign best I can. So we did emphasize that you do all of these things on paper first. Then you come and click on the computer. Do not fall into the trap of trying to do everything on the computer. No, you do everything on paper first. Get your picture by hand. This is a mathematics learning is an analog activity. Clicking stuff on the keyboard is not going to get you there. So this is the graph here. Okay. Now, what we did then, what we learned is the point tracking. So I invited you to think about, well, what kind of movements cause this final set of points. So what I strongly recommend is that you pause this video and you go think for yourself, and then you come back to see if what you thought is matches what we say here. So let's all of those examples before, they had some pi here, but just I'm removing that so that the conversation becomes a little bit easier. So we always have some sort of input. I hope you listen to me and you pause and you're coming back. So this is the input. So let's call this input. This is our input convenient angle A. Let's call it this thing A. So my A input is 2x plus 6. Question is, we are doing a substitution. Instead of x that we had at the beginning, we are putting this A, which is like 2x plus 6. What kind of shifting, compression, or stretching is going to be caused by this? Very easy. In all those processes, you notice that we go try the angle x itself. So from this input, this is my A. I try to figure out what x is, and everything happens into the x's here. So I come and say, well, in general, what do you say? A minus 6 is 2x. So x is A minus 6 over 2. Or you can think about it as A over 2 minus 6 over 2. Or you can rewrite it to make it easier for us to talk. A over 2 minus 3. Whatever the angle is, that famous angle gets divided by 2. And then we subtract 3 from it. So dividing by 2 now is going to be understood exactly what it says. Dividing means making things smaller, making things compressed. So this means, if you, that's how you write it, how you read it, this means compressed by a factor of 2. And this means what? This means now we read it exactly what it is. We don't flip the operation. Uh, it's not like this anymore. Here we're saying plus 6 means left by 6. So here's adding, and then we say something paradoxically. Addition means moving to the left. This is where that comes from. So this is, you see, you do exactly what you see here. So there's no need to change anything. This means left by 3. So now it conforms to your intuition. You don't need to change it. Division means shortening or compressing. So compressed by a factor of 2 and then left by 3. You had the option of leaving it like this. Leaving it like this, x is equal to a minus 6 over 2. Well, order of operation is different here. You subtract 6 and then divide by 2. If that is what you want to do, this means left by 6 and then so this first action and second action is compressed by 2, meaning all the x's get compressed by a factor of 2, as opposed to what did we do here. The order operation is that first you do compression and then you do shifting to the left. If you want to exchange the order of operation, you have to go left by 6 and then compress by a factor of 2. So what we did here is a higher level mathematics than that point tracking. Point tracking we do first brute force, we learn what's going on, and after repetition we put all the pattern together to see, well, what happened here. What happened is now being compressed in all of this. So what is the moral of the story? Moral of the story is following. If you take x and replace it by something like 2x plus 6, the shifting or transformation that you're going to get is according to the inverse function of the substitution. That is what this thing is. This thing, this is inverse function of the substitution. So transformation is according to inverse function of the substitution. Okay, I hope so. The last 10 minutes we had additional conversation here. If you followed this thing and you are willing to do that kind of work to understand that, you are a very good candidate for a mathematics degree. Okay, so our conversation this time was a lot more than just a mini lecture. In fact, it was perhaps the most significant lecture since the beginning of the semester, and all of that had to do with the following idea. Okay, other than that, if you have a still hard time with this thing, which is quite understandable, make sure you go and understand how to do the point tracking. Repeat this problem over and over again. So we did 4 of them here. Repeat the problem, match it against the transformation we explained here, and you will get it. So for example, here let's look at this. Here my a is 3x minus pi. So when I rearrange this thing, x becomes a plus pi over 3, or if you wish to think about it as a third plus pi third. Each of them means something. This one, if you do it this way, this means compressed by 3. Okay, so that's why this thing is a lot narrower than before. Cycle used to be 2 pi. Now the cycle is just 2 pi third. It's got squished by a factor of 3. If you do like that, and then next move exactly what you see. Do not change this thing anymore. So you're already done. Plus pi third means right by pi third. So here it's quite obvious that we took this thing and squished it by a factor of 3, but then we moved to the right by pi third. So that's perhaps more visible. We squish it and then move by pi third. If you wish, you can go to take the picture, move the entire thing to the right by pi, and then squish it by a factor of 3. So that's that's a different kind of set of steps you go through, but the final result is the same. That's the interesting part of it. So this means step 1, you go to right by pi, and step 2, you are going to compress by 3. Okay, so once again, what we said at the end is optional, just for your benefit if you are interested. Okay, so I guess that's enough for one lecture. So until next time, good luck and God bless.